Okay, now we're going to talk about one of the new options for the Agilent X-Series Spectrum Analyzer that's particularly nice for people who are making EMI measurements, and this is option EDP, the Enhanced Display Package. So the Enhanced Display Package gives you three new views. If you go to the View Display menu, you can see that you have the spectrogram view, the trace zoom view, and the zone span view, in addition to the normal view. And if you don't see this view menu, then that means you don't have option EDP. Now, the easiest way to get into one of these views is to simply press the split window hard key on the front panel. And this key appears below the display. It looks like two rectangles, one on top of the other. If you press this key, then it will put you into the zone span view by default. So let's push the split screen key, and that puts you into the zone span view. Now the zone span view may be familiar to you if you remember the ESA spectrum analyzer, because it had zone span as well. What zone span does is it takes the sweep from the normal view, puts it in the upper window of the display, and then in the lower window you see a zone from the upper display. The zone is outlined with this orange region here. You can move the zone around by adjusting the zone center control. I'm turning the knob now to adjust the zone center control. Now, the zone by default is 10% of the display region in the upper window. So by moving it around, you can see that I've got the ability to zoom in on some of these signals that I can see in the upper window. The upper window doesn't sweep. By default, the lower window is active. The active window is the one that has the green border around it. And it's also the window that has the focus. In other words, the soft keys are sent to that window while it has the green border. You can press the next window key. That's the key that looks like two little rectangles with arrows connecting them on the front panel. And when you press the next window key, then the upper window becomes active and it sweeps. And then the next window again, and the lower window is active and it sweeps. So the basic principle for zone span is you take a sweep in the upper window of the full range of frequencies in which you're interested, and then you can move through them with the zone region in the lower window, examining each one in more detail. Now, the zone region can be changed by moving the zone center around, as we've seen, or if you go to span, you can adjust the zone span, which is the width of the zone region. So as I adjust the zone span, you can see that the orange region gets narrower and the bottom window gets wider, because it has the start and stop frequency that are determined by the zone region. Okay. Now, the other thing that you should note is that the settings in the lower window are largely independent of the settings in the upper window. For example, I can change the attenuation in the lower window to 0 dB, and it doesn't have any effect on the settings in the upper window. It changed the amplitude scale of the lower window. It didn't affect the upper window. I can change the bandwidth of the lower window. I can adjust the bandwidth up or down, and it won't affect the settings in the upper window either, but it may allow me to get a little more insight into the signal in question. Okay, so the ability to zoom in on signals and measure them with parameters that are different from those in the upper window is really quite powerful, and particularly when you're making EMI measurements. For example, I can roll down here to the FM band, and I can see the individual FM stations. I can go to one of them and demodulate it or look at it more closely while retaining the original scan of the entire frequency range. So that's the zone span function. A function that's similar to zone span but different is the trace zoom function. When I go to trace zoom, now what I'm seeing is the same trace in the upper window and the lower window, but I'm seeing only a part of that trace in the lower window. I'm zoomed in on the trace rather than, as in zone span, being zoomed in on a particular signal. And in the case of trace zoom, the settings are the same largely in the lower window as the upper window. The only thing that's different is the start and stop frequency. So now my amplitude scales are identical, but my frequency scales are a little different. And if I want to zoom in more on the signal, I can do that by changing the width of the zoom region or the zoom span. And as I adjust that, you can see that the blue region narrows, and now I'm getting even in tighter in the lower window. Now, one of the real values of trace zoom is when you're using a lot of trace points in the upper window. So you can see here I've got 16,000 points. Remember, I can have up to 40,000 points in the X series. So I got 16,000 points in the upper window, but in the lower window I'm zoomed in on the trace, and yet I still have pretty good resolution on that trace in the bottom window. So if I move the zoom region down to one of these signals, I can resolve those points more clearly than I can in the upper window. Now, if you go to the upper window and set the sweep points there to the maximum, which is 40,001, then you can really see the value of trace zoom. So if I set the analyzer to its full span and then move the zoom region down here to where there are all these signals, and you can see that even though they just appear as lines on the upper window, they resolve themselves much better as signals in the lower window. So this counters the effect that is sometimes known as pixelation, where you're displaying so many more points in the trace than are visible on the display that it really helps to be able to zoom in on a particular region. Now, there's one thing that's very special about the zoom region, and that is that if you do a peak search while the focus is on this region, the peak search will be confined to that region. So let me go back down to the lower window. Now I'm on the lower window. I do a peak search, and it's finding the peak in the lower window, even though there are peaks in the upper window that are clearly higher than the peak in the lower window. So this is really nice if you want to display a number of signals in the upper window, but when you do a peak search, you want it confined to a particular region. Just set the lower window to that region, put the focus on the lower window, and do your peak search down there. Now you can see in this lower window that I've got a signal that's coming and going. And when you're looking at signals like that, it's really nice to use the next display function of the enhanced display package, and that's the spectrogram view. So let's switch to the spectrogram view now, and let's narrow our span. Let's first of all move the marker to the center frequency, and now narrow the span so that we're looking more closely around that region. And there's that signal that was coming and going. When you look at it in the spectrogram view, you actually can see the signal coming and going. And we can actually make some measurements of the dynamics of that signal. Now the spectrogram is, what you're doing is you're mapping signal levels, the amplitude axis in the upper window, to colors. So one of the things you can do if you want to make your colors more useful is put your mechanical attenuator in manual and then adjust the reference level so that the regions, the color regions, move. You can see that the eye has sees contrast better between some colors than others. And so now this signal that's coming and going, I can see it as these little red regions over here in the bottom window. And if I stop the sweep by pressing the single key, now maybe I can go and take a look at some of the time differences between these events in the lower window. Now when you're in the lower window, you have this function called display trace, and I'm turning the knob now to move the display trace through the spectrogram display. And you can see as I go, look at the upper window change trace by trace as I move the display trace through the upper window. So there's an event taking place. I see it very clearly in the upper window. If I do a peak search now, it's always going to search on the current trace. So it just basically put the marker on the this signal in the upper window. I can lower the reference level a little bit so that I can see the marker. Okay, so you can see the same marker down here in the lower window. Now I can go to the marker properties menu and marker Z, which is basically which trace the marker is on. It becomes the active function. So now I can move that marker in the Z-axis, or if I make the marker the active function again, I can move it in the X-axis. Okay, so the most useful thing to do if you're trying to measure the difference between two events in time is actually to adjust the trace, the display trace, so that it's showing you the events on the different traces. So let's put the marker on that first display trace again, and now let's hit delta. And now we'll move the display trace to a different region, to a different trace, and where the event is occurring again. Let's find another place where that signal is of a pretty good amplitude. And now let's push peak search again. And now you're actually measuring the time delta between these two events in the lower window. And you can see it up here, minus 3.35 seconds, showing you the difference between those two events. So this spectrogram view gives you the ability to actually make time delta measurements between events that are more clearly seen in the lower window. Now the lower window has the last 300 sweeps that were done in the upper window show up in the lower window. So if you're wondering what the size of the capture buffer is, it's 300 sweeps, because this is a spectrogram that's allowing you to display the history of the swept spectrum analyzer. It's not like the spectrograms that you might find in the 89601 VSA software, where those spectrograms are done by capturing a lot of time data and then turning it into traces and looking at the traces in a spectrogram view. This is simply the last 300 traces that were swept in the upper window. Okay, so this is more like a swept spectrogram. So there are the three new views that you get when you buy option EDP, and it's a very useful option. So hopefully you'll be able to apply option EDP to your EMI measurements very effectively.